Welcome back. Problem number 2222, numbers of ways to select buildings. You are given a zero index binary string called S, which represents the types of buildings along a street where S of I equals 0 denotes that the ith building in the is an office, and S of I equals 1, and this denotes that ith building is a restaurant. A city official, you would like to select 3 buildings for random inspection. However, to ensure variety, no 2 consecutive buildings out of the selected buildings can be on the same type. Like, for example, we have this string. We cannot select the first and the third and the fifth buildings as that would form 0, 1, 1, for example, which is not allowed due to having 2 consecutive buildings of the same type. So let's make a recap here. We need to imagine that you are given a street with buildings arranged in a line. Each building is either an office, which is 0, or restaurant with 1. The buildings are represented as a string where 0 means office and 1 means restaurant. And the task is to select 3 buildings for inspection, but there are rules. No 2 consecutive buildings in your selection can be on the same type. So for example, if we have this string, you can select buildings at position 0, 2, and 4, 0, 1, 0, because no 2 consecutive buildings in the selection are the same type. So you need to count all possible valid ways to select 3 buildings from the given string such that no 2 consecutive buildings are on the same type. Okay, how we can do that? There are multiple approaches to do that. We can just loop and just try to compare, but this will be inefficient in being strings. There are better way, in my opinion, that comes through 3 steps. So we could create like initialize like a counting arrays. Like initialize a counting arrays, which will be, we create a prefix array and suffix array. The prefix will create arrays to count the numbers of zeros and ones and set up each position. And we create a suffix array because we will create an arrays to count the number of zeros and ones from each position to the end. So we create a prefix array to count each number from the beginning, and a suffix array to from the end. But let's try to think about why we will go into this one, because okay, so the goal, we want to efficiently count the number of valid triples, like subset of 3 buildings of in form of 0, 1, 0 or 1, 0, 1. The prefix and suffix array, why do we need them? So without a prefix and suffix arrays, we would need to repeatedly scan parts of the string to count zeros and ones before and after each position, which would be very inefficient in large strings. Instead, we pre-computed these counts once and then use them to quickly determine the number of valid triples. How this will work? For example, we will have the prefix arrays, which the numbers, it will be the numbers of zeros or ones from the start to from the start of the string up to the index I, and the suffix of the string, it will be the number of zeros or ones from the i's to the end. So this is the reason why we're using the prefix and suffix strings. Okay, let's try to jump in the code directly. So first, we will have I and 1. So we will create 4 arrays. The first one, it will be a prefix of 0, which will equals new array dot of in, and we will fill it of 0. And it will be prefix of 1, and we have also suffix of 0 and suffix of 1 of 1. So we initialize all the variables that we need. The first thing that we need to do is to compute prefix count. As we said, prefix is from the start until the current position. So we will say we need to compute prefix count. We need to count okay. So we will make a loop. We'll loop through the string. Let I equals 0. I less than okay, I will create another variable because I guess we will use s.length a lot. I will be less than n and I plus plus. So if I is bigger than 0, we will do the coming. First, the prefix 0. The prefix 0 of I will equals its previous. So it will equals prefix 0 of I minus 1. And the same I will do, the same I will do for the ones. Okay. And after that, I would say if s of I equals 0, I will make prefix 0 of I plus plus. I will add 1 to it, and else it will equals 1. So 1 it will be plus plus. Okay, let's try to describe the code here. So this code is responsible for computing the prefix counts of zeros. In this one here, as you can see, for each position in the given string, these prefix counts help us quickly determine the number of zeros and ones that up to any given position in the string, which is crucial for counting valid triples of the building. So in the beginning, as you can see here, we loop through the string. We start looping that iterates through each character in the string s, and I is the current index and n is the length of the string. We have two blocks. The first if statement here, like for each I, if I is greater than 0, like not the first position, because we don't want the first position. We can do something better actually. We can just make I equals 1 and remove this if statement. Also, like we initialize the prefix of I and the prefix of I1 and prefix of I0 with values from the previous positions. This means that the current count of zeros and ones starts as the count up to the previous position. And after that, we need to update the prefix counts based on the current character. We check if the s of I is 0, we update it, is 1, updated. So the summary in this one, the loop calculates the cumulative counts of zeros and ones up to each position in the string, and this is the purpose of it. Right now, we need to compute the suffix. I guess we will do the same, but we will do it from the end, not the beginning. So let's do the suffix. So for let I equals n minus 1, I bigger than or equals 0, and I minus minus. And I would say if I is less than n minus 1, so it's not directly from the end. I will take the suffix of 0 that will equals suffix of 0 of I will equal suffix of 0 of I plus 1, and the same it will be with 1 here. And we will do the same here. I'll say if let's just copy this code block here. Okay, so I will say if s of I equals 0, the suffix exactly. So yeah. So this is the same actually the prefix, but we're just starting from the end to the position, and the prefix we're starting from the beginning to the current position. Right now we need to calculate the number of the valid triples. So in order to do that, first let's start by creating a variable called result. Let's just put the variables here. And I need to return the result because I always forgot to return a result. Okay, so I will make a for loop. I'll say let I equals 1 and I less than n minus 1. We're not calculating the end or the beginning, and I should be plus plus. And let's try to think about how this code will work. So if s equals 0, if s of I equals 0, the result, I will add the result plus equal the prefix of I minus 1 multiplied by the suffix of I minus 1, because the beginning and the end. Of I minus 1. And if was else the case, it will be the same, but instead of no, I did it wrong. If I equals 0, the prefix of 1 multiplied by suffix of 1, but here plus 1, not minus 1, and here is plus as well, not minus. Okay, let's try to discuss this code. So we start looping iterators through each character in the string from index 1 to n minus 1 or minus 2. We avoid the first and the last characters because we are formatting triples, and the middle characters of the triple cannot be at the edges. Okay, so we need to check the current character. If the current character is 0, for each character at the position, we check if the characters are 0 or 1. And after that, we need to calculate the valid 0, 1, 0, or the valid triples. So if s of I is 0, we're looking for triples of the form 0, 1, 0. Okay, so if we're looking for that, the prefix of I minus 1 gives us the number of ones before the position I, and the suffix of the suffix 1 gives us the number of ones after the position I, and the product prefix 1 minus I minus 1 multiplied by suffix 1 I plus 1 gives us the numbers of ways to form 0, 1, 0 triples with 0 at position I. After that, we have also calculate if the number is not 0 and it's 1, that means we are searching for 101. And if we are looking at this way, if s of I equals 1, we are looking for 101, and the prefix I minus 1 gives you the number of zeros before this position, and suffix of 0 plus 1 gives us numbers of 1 after this position. And the ways to perform 101 is to multiply these numbers with each other. And yeah, this is how it works. Let's submit and see if the code will work or not. Okay, it did work. We can take an example on how this will work. We can just okay, let's see how we can we take an example? I guess no, because we are too long on the video already, and I guess no, there is no need to give an example for that. So yeah, that's it for this solution, and yeah, I hope you like it.